Hey guys, my name is Trevor Sullivan, and welcome back to the StratusGrid YouTube channel. I'm a solutions architect on the StratusGrid sales team, and in this video, I wanted to continue our series on Amazon DynamoDB with Rust. There's a specific feature that I wanted to cover in this video, which is known as DynamoDB transactions that allow you to perform atomic operations against a DynamoDB table. Now, if you're not familiar with the term atomic, it basically means all or nothing. We can specify more than one transaction that we want to operate on for a particular item, and then we can actually batch those all together into one large transaction that has multiple operations within it. And then we can send that off to the DynamoDB API and affect all of those items. And if any one of those operations were to fail, then the entire transaction will be rolled back to the previous state. Now, there's a lot of things to know about transactions when you're working with them. One of the unique features with transactions is that you can actually span multiple tables as long as they're in the same AWS account and region. So that's something that's a little bit unique when you're interacting with items and making changes to items across multiple tables, is that you can do that, but they do have to be within the same account and region. So if you're interested in engaging with us, I'd encourage you to head over to our website, which is stratusgrid.com. You can also head over to our YouTube channel where you're probably watching this video. Make sure you subscribe to the channel and get updates about future videos. And also check out the playlists that we have featured on our channel homepage here. We've got a Rust development and AWS playlist here. We've got one on our cost savings optimization tool called Stratosphere. We've also got other AWS videos that aren't necessarily related to the Rust SDK for AWS as well. So feel free to check this out. And if you go to the videos tab, this is just all of our latest videos sorted in chronological order. So make sure you subscribe to the channel there and leave a comment. Let us know what you'd like to see on our channel pertaining to AWS and especially Rust as well. So what we're going to be doing is talking about the DynamoDB transactions here, and I would encourage you to head over to the developer guide. So if you head out to the AWS documentation, drill into the DynamoDB service, and then go under the working with DynamoDB, and then go down to working with transactions. And there's a couple of articles here, kind of this homepage here, and then also how it works here that goes into a lot of depth on how exactly transactions work. Now, this is part of the DynamoDB crate for Rust. So if you've watched any of the other videos where we've been using the DynamoDB crate to do different types of operations like queries or scans or inserting items into a DynamoDB table, then all of those are going to be part of the same crate. You don't have to worry about installing a separate dependency into your Rust project because the transaction, the batch capabilities, the put item, get item, all those individual APIs, they're all part of the same crate. Now, there's really two APIs that we are going to be taking a look at when it comes to transactions. We have the ability to get items, so that's just kind of a read-only operation. And then we also have the items API here, which is quite a bit more complex just due to the nature of different types of write operations that we might be performing. When you take a look at the write operation here, we actually have the ability to perform individual actions. So we can put a new item, we can update an existing item, we can delete an item from a table, and we also have this kind of unique thing down here called a condition check. And this doesn't actually perform any write itself. What the condition check does is it says, I'm only going to allow this entire transaction to occur. Remember, these are atomic operations, so they have to be all or nothing. And so the condition check basically is a way for you to validate a condition in a particular item in a table before the transaction will be allowed to be committed to the affected tables and items. So that's kind of a unique thing that's available in this API as well. But really the kind of CRUD operations that we have are put, update, delete, and then also on the transact get items API here, we also have the get action that we can perform. So when we're talking about things like get or the put or update, delete, and condition check, all of those are what we call individual actions inside of a larger transaction, right? So a transaction can have many, many different actions that affect individual items inside of them. Now, you might be wondering, if we're going to use transactions, why don't we just use the batch operations? What's different between batch operations and transactions? Well, both of them can span multiple tables, so that's not unique. But something that is unique with transactions is that you can actually have a 4 megabyte payload, which is a little bit smaller than batches. So if you're doing bulk data uploads, you're actually better off doing batches because those can be up to 16 megabytes per request, significantly larger, 4 times larger than transactions. But transactions at 4 megabytes are actually larger than things like query operations or scan operations that limit you to 1 megabyte payloads in the response if you're doing read type operations. So that's something that's unique about the transactions, is that they do support larger payloads than some other APIs, but not the batch APIs. But then something else that's unique about transactions is that it's all or nothing, right? So that atomicity attribute that we have with transactions is unique to transactions. You don't get that with batch. In batch operations against DynamoDB, you could actually have a subset of those individual actions that we specified. So we could have one put that succeeds, but then 5 puts that fail. And the DynamoDB service isn't going to roll that back just due to the failures. It's actually going to allow that kind of inconsistent state to occur. And so if you really need that atomicity, then you'll want to use something like the transaction API. Also, something about transactions that is unique is that you can batch together up to 100 actions individually, all at the same time. So if we take a look at the documentation here, we've got transact write items that allows us to do up to 100 write actions per request, right? So that's a really unique thing about transactions as well, is that you're not restricted to just doing single operations on individual items. You can actually batch those together into a very large transaction with up to 100 individual actions that we perform, and then commit those all at the same time. Now, something I do want to note about the transactions here is that when you specify these individual actions, you can only target an item once. So if I target an item with a put operation, I cannot also create an action that has a delete operation against the same item in the same table, because otherwise those would conflict with each other and DynamoDB wouldn't have any way to kind of sort out that conflict. So just keep in mind that when you're targeting an item, it can only be referenced once inside of a transaction request. You can always create additional transaction requests and affect those same items in the future, but each individual transaction that you're assembling with up to 100 actions inside of it can only reference an item a single time. All right, so let's go ahead and talk about how we can actually use the transactions feature in our DynamoDB tables with Rust specifically. So I've got a video over on the StratusGrid YouTube channel here, and there's actually a corresponding blog post that goes with this as well. But we actually introduced the concept of using the Rust SDK with AWS in general. And we also have a video that covers an introduction to DynamoDB specifically. So that's called Build a Product Catalog with DynamoDB and Rust. So if you're looking for kind of foundational knowledge, look for that video or this one called Managing Cloud Resources with the AWS SDK and Rust, because we're going to breeze through some topics that might allow you to dive deeper if you watch those other videos. All right, so let's go ahead and take a look at the crate that we're going to be using. So we're going to head over to crates.io right here, and we're going to be taking a look at the DynamoDB crate right here. So all of the crates are prefixed with AWS SDK. So we're going to look for that one for DynamoDB. And so there's crates for each individual service. If you want to do S3 or EC2 automation, you can just install the appropriate service crate, and that helps to keep your project relatively small as you're developing it. It just keeps a bunch of unnecessary code that we're not referencing out of our project. So we're gonna go ahead and spin up a new project. We're gonna reference this crate. We also have to set up our AWS credentials as well. So we're gonna head over to our AWS account right here, go to the IAM service, and then we're going to create an IAM user with some credentials. I'm just going to call this Trevor DDB delete me dash video. And then we'll go ahead and say that we want to attach a policy. This is the permissions that we're granting to the user. So I'll search for DynamoDB. And there's a pre-built policy that should be available in every single AWS account. It's called a managed policy called Amazon DynamoDB Full Access. So once we've attached that to that new user, we can go to the user, go to security credentials. We'll say create an access key. Just choose the other option right here. And then I'll just hit create access key. You don't have to plug in a description if you don't want to. And then we'll just copy the access key ID and the secret access key. And those will be the credentials that we can use to work with the DynamoDB service locally. All right, so now what I'm going to do is create a project folder. And I'm going to go into my root git directory over here. I'll just do a cargo new, and we'll specify a name for the folder like DDB transactions. I'll also prefix it with SG here. And then I'll go ahead and open up Microsoft Visual Studio Code. I've already got VS Code installed along with the Rust tools, obviously, because that's how I got the cargo CLI here. So if you want to install Rust, go check out the other video that talks about getting started with Rust and VS Code and all the other kind of dependencies that we have as a developer. So we're going to go into this folder here and open that directly up in Microsoft Visual Studio Code. And then I'm just going to check to make sure I have the Rust Analyzer extension installed here as well. I should, but there could potentially be an update for it as well. So it looks like I do have it installed, and it doesn't look like it is updating. So we should be good to go to start actually writing some code. Now, one of the things I like to do is just create a simple script here to set my credentials. I'll just call this AWS credentials.ps1. So if I ever have to restart Visual Studio Code, I can just run this script really quickly to reset my credentials. And because I'm using PowerShell here, I'll use $env AWS access key ID, and we'll specify our access key ID. We'll duplicate that down and say AWS secret access key, and we'll set that to our secret key, and then we'll say env AWS region and set that to US West 1. Of course, you can use whatever region is most appropriate for you. Then I can just run this PowerShell script in my terminal right down here, the integrated terminal in VS Code. And now I've got those environment variables set up. And when we use the Rust SDK to instantiate a client object, we'll actually automatically pick up on these credentials here. Actually, it's a SDK configuration object, but we'll take a look at how to do that in just a moment here. Now, at the moment, we have nothing in our cargo.toml as far as dependencies go. This is a brand new project, so of course we don't have any dependencies. So as with the other videos that we've done against AWS APIs, we are going to do a cargo add Tokyo features full. And this is our asynchronous runtime that allows us to run async code. And there are other async runtimes out there as well. They're called async executors in Rust, like small SMOL. That's another executor that's available. But Tokyo is by far the most popular, so we're just going to utilize that. And then we're also going to do a cargo add AWS-config features behavior version latest. And we'll do the same thing for the DynamoDB crate. So let's go back here and say AWS-SDK-DynamoDB. And so now all of our dependencies should be installed locally here. Rust Analyzer doesn't always necessarily pick up on these changes. So I'm just going to hit F1 or Control-Shift-P or Command-Shift-P if you're on Mac and do a reload window operation here. And that should kind of kick the Rust Analyzer into gear and start building out the IntelliSense or the auto-completion inside of my editor here. So now we're ready to go ahead and start writing some code. Back in our main.rs file here, we're going to add the Tokyo main macro, and that'll allow us to have an async main function here as our entry point. And so basically that's just expanding out into some code that will spawn the async runtime and kick off our main function as the entry point to our application. So now I'm going to define a separate function down here for us to test out transactions with so that I'm not kind of gumming up my main function here. I'll do a function here called test get transaction, maybe get DDB transaction just to be a little bit more clear there. And what I'm going to do is up in the main function, I'm going to set up our SDK configuration for AWS. And then I'm also going to instantiate the DynamoDB client. And then what I'll do is I'll be able to pass through the DynamoDB client as a borrowed value as a parameter to each of our functions here. I'm actually going to turn this function into async here. And then I'm going to go ahead and load my configuration up here. So we'll do AWS config load from env, and then we'll await that because that is an async future that we need to await in order for it to actually trigger. And then we can assign the SDK configuration to a variable like SDK. This dark gray text right here that says SDK config, that is an inferred type because the Rust analyzer extension knows that this function here returns an SDK configuration through a future. So once we await that, it's ultimately going to return this SDK config data structure. So that's not actually part of my code. It's actually just inferring that and then displaying it in line to help me as a developer know what data type I am dealing with here. So once we've loaded our credentials and AWS region from environment variables, that's just one of the default locations that the SDKs look for credential configurations. Now I'm going to go ahead and create the DynamoDB client. And if you've watched any of my other videos, you've probably seen me use AWS SDK DynamoDB as DDB for short, just so we can easily reference that in our code. So then what I'll do is instantiate the client and we'll assign it to a variable like DDB client. And then I'll go to the DDB crate, grab the client data structure here. We'll say new, and then we can borrow the SDK configuration in order to instantiate the client. So I'll do ampersand SDK. And now we have a client data structure from the DynamoDB crate. So now this DynamoDB client or DDB client variable here contains all of the different functions that we can call against the DynamoDB REST API. And if you ever want to reference the REST API documentation, you can always head back over to the DynamoDB documentation here. I'll just open this in a new tab, and we'll go down to API reference instead of the developer guide. And if you go to actions here and then DynamoDB, this is where you can see all of the individual APIs that we can call. And we're going to be dealing with the transact get items and the transact write items as well. And so just to take a quick look at the input data structure here, we have this top level property called transact items. And this is an array because again, we can have 1 to 100 individual actions that we want to perform against different items in DynamoDB. And so with transact get items, we can only perform a get operation here. So all we would have to do is specify the partition key as well as the sort key, also known as the hash and range key of the item that we want to retrieve from a table. So let's start by doing just a simple get transaction and see how this works, since there's a lot less complexity to the get operations as compared to the write operations. We also have the ability to project certain attributes. So if we want to include certain attributes in the response and omit other attributes, you can also use that projection expression. But by default, I believe it's just going to return all. So yeah, if no attribute names are specified, then all attributes of the item are going to be returned. So we don't have to specify that in our request. Let's go take a look at the request again really quickly. And we do need to specify transact items because that's how we specify the array of get actions that we want to perform. We don't have to specify this here, but if you do want to know how much table capacity was consumed for kind of pricing information, that kind of thing, then you can tell it that you want to return the consumed capacity and then plug in either indexes or total as values as inputs to that. Let's skip over transact items there. Actually, part of transact items is the table name here. So each of the individual get operations here is going to specify a table name. And that's because since we have an array of individual transact items that we want to perform or actions that we want to perform, then each of those get operations could target a different table and a different item in that table. And so that's why we have to specify the exact partition key and sort key, if applicable. You don't have to have a sort key, but we also have to specify the table name for each of those actions, because again, all of those individual actions in this transaction could target a different DynamoDB table in the same AWS account and region. So that's why we see the table name underneath of the get operation here, rather than being kind of at the root level here, where we would just be able to operate over a single table, right? So that's why it's part of the individual get actions here. All right, so what we're going to do is go back to our code here. We're going to accept this DDB client as a parameter here. So I'll just say DDB underscore client. I'll just use the same argument name as the variable here, and we'll make it of type borrowed client struct. And we'll need to prefix that with DDB so it knows what crate that data structure belongs to there. And then what we can do is just call test get DDB transaction. We can do ampersand DDB client, and then we can do dot await, because this is an async function which returns a future, and ultimately we have to await it in order for it to actually get triggered by the async executor, which again is going to be Tokyo in this case. All right, so that's all kind of the boilerplate stuff that we need to do. Now what we can do in order to actually build out a get transaction is go ahead and start writing some code inside of here using this DynamoDB client object. So what we're going to do is say DDB client dot, and then I'm going to type transact here, or part of that. And you can see I've got transact get items, transact write items. So those are the two different APIs that we really want to look at. There's also execute transaction, but for now we're not going to take a look at that. But what I'm going to do for starters is call transact get items and kind of work backwards from here to take a look at the different inputs that we have to construct as Rust data structures. So if we go ahead and do another dot after that, what we get back, let's actually assign it to a variable. Let's call it get transaction. And then what we'll do is do a period at the end right there. And so then we can see we've got this method here called transact items that allows us to add individual transact get item data structures into this request. We also have return consumed capacity here. So again, that's this little property up here that allows us to tell DynamoDB if we want to have that returned as part of the response or not. And then the only thing that we really have to worry about here is the transact items, right? So let's construct a transact item that we can pass into this transact items operation here. And I'm just going to format things here on a new line so we can see all of these individual operations that we are performing. And again, this darker gray text right here is just the data type that's being inferred from the operation, the expression that we're calling on the right-hand side of the equals operator here. Now, with any API from AWS, we also have to call .send.await as well. So that'll finally give us the result type here after the API has actually been called. So we have to call send to turn the operation into an async operation, a future. And then we have to call await for Rust to actually trigger that future with the async runtime. So now what we need to do is to kind of fix things up here. We need to be able to pass in one of these inputs, which we don't currently have defined, right? So before we actually call the API, I'm going to add another line where we construct the transact get item data structure that we need to pass in to this method right here. And what I'll do is refer you to the documentation. So if we go to docs.rs, this is the Rust documentation site. And if we search for the DynamoDB crate, so search for DynamoDB right here, and we're looking for AWS SDK DynamoDB, then we can drill into modules here. And let's see, what are we looking for? We are looking for the transact get item. So we're going to just do a search here at the top for transact get item. And as you can see, under the types module inside of the crate, there is that data type. So we can go to modules, and then we can go to types. Let's go to the root here, go to modules, go down to the types submodule, and then we can look through the data structures list here and find the data structure that we need in this huge list. So we have data structure for transact get item and transact write item as well. And the transact write item is where we have things like put, delete, update, and check condition. But for now, we're going to focus on transact get item. And this is basically just a wrapper around a specific get operation. And it has the data type of option wrapping get. So technically that could have a none value, like an empty value, but we're always going to have a value. But just be aware that this is wrapped in an option. So we may have to do additional unwrapping depending on how we're interacting with this data type here. But for now, all we want to do is build out one of these data structures, the transact get item. And to do that, we can just call the builder function on that data type, and that will give us a transact get item builder, which is part of another submodule called the builders submodule under types. And so all these builders allow you to call different functions. In this case, we just have a get function here that accepts the get operation or the action that we want to perform on a specific item. And then you'll notice that we actually have another operation here, or another data structure called the get data structure, and that's right under types as well. And so we're once again going to use the builder to construct one of these get operations. We're going to wrap it in the transact get item, and then we're going to add the transact get item data structure to the transaction request before we send it using this transact items right here. So let's unwrap things a little bit. Let's go back one step and create a transact get item. So I'll say get item 01, because we could have up to 100 individual items here. And then we'll do transact get item builder. And then we'll go ahead and specify the get function here to add our individual get action to the transact get item wrapper. And so now we have to actually construct that get right here. We also have to call .build at the end here because right now we have a builder. So we have to call the build function to turn that builder into the underlying data structure that we're trying to get access to. So now let's go back another step. Well, let's actually substitute our variable here, get item 01, for that input variable there. And that satisfies the compiler's issue with that. And then we also need to construct this input here. So this is going to be the get data type. So what we're going to do is say let get action 01 equal the, let's see, we want the get data type here. So DDB types get, and we'll just automatically import that right up here. The Rust Analyzer extension will do that for you. So I just hit enter on that. And then we're going to open a builder here. And then we want to configure the builder with all of the necessary operations here. So under get, we have the table name function that we want to call to configure the table name. Then we want to specify the key here as well, and that'll be the partition key and the sort key of the item that we want to affect. Remember that in DynamoDB, when you have a partition and a sort key defined, the partition and sort key together are called a composite primary key, and that's how we reference a specific item uniquely in the table. And then we also have the optional ability to specify a projection expression if we want to include specific attributes, but we're just not going to configure that because we want all of them. And then we also have this expression attribute names, but that's only if you are utilizing a projection expression here. So we're just going to focus on the table that we want to retrieve and the specific item keys that we want to retrieve. And I already have a table created. So let me just show you the data that we're trying to retrieve. So we'll go over to the DynamoDB service, go over to tables. I'm in the US West 1 California region here. Then we'll go to Trevor-products. And if I go to explore table items, you can see that I've got 8 items here in my table called Trevor-products. And any of these items here I could return. My table schema is P category is the product category, that is the partition. Then I've got a sort key, which is the product name or P_name attribute. So as we are looking at these items, if I want to retrieve a specific item like the kitchen fork, then my P category is going to be set to kitchen. My P name is going to be set to fork. And those are the 2 keys that we have to use in order to retrieve a specific item. All right, so right up here on the builder, let's start a new line here. And we'll say dot table name is Trevor-products. And then I can do dot key. And then I can specify the key and the value. So the key in this case is going to be the attribute name, which is P category, and the value. And if you've watched my other videos, you've probably seen this data type called attribute value that basically wraps the underlying value. So in this case, we have a string type. So we're going to use the attribute value s, not ss, that's a string set. And then we're going to pass in the string that we want to check for. So in this case, we want kitchen, and we'll call that toString on that because it has to be a heap allocated string. Then I'll just go ahead and duplicate this down one more time, and we'll say the p name attribute should have a value of fork. And obviously you'd want to prompt a user for this information. I'm just going to hard code it for simplicity for the time being, but generally speaking, you would prompt the user to, input a partition that they want to retrieve, then, input a sort key that you want to retrieve for a specific item, and you could go from there. But again, I'm just going to hard code it for now. So now we've configured the table and the two keys that we need to retrieve a specific item from the table here. And so that's everything that we need to worry about. We don't have to configure either of these other projection expression or expression attribute names. So now what we're going to do is just call the .build function to turn this get builder into a result. And I think that's going to get a result there. So we have to do an unwrap on the result to get the underlying get data structure. All right, so now we can take this get data structure and pass it into our transact get item here. And so now we've added that action to our transact get item, and then we append the transact get item wrapper into the actual transaction request. So that's pretty much everything that we need to do here. We could add a second item, so we could add a second get operation like this and a second transact get item data structure here, and then append all of those using transact items multiple times. We could actually duplicate this multiple times and reference different data structures that we instantiate, but for now, we're just going to get a single item. So as far as retrieving the data goes, that's all we should need to do. Let's go ahead and test out this code really quickly and see what happens. So we'll do a cargo run. This will compile all of our dependencies and ultimately run our Rust application. So I want to make sure, sometimes I forget to call the function from main. So I am calling the function from main there. We're passing in a borrowed reference to the DynamoDB client. So I don't see any errors here. I think it's just saying that we have an unused variable from our final result here that we get, but that's totally okay. We'll use that in a second to retrieve specific attributes from the transaction results that we get back. All right, so it looks like we didn't get any panics, which is certainly a good sign. So that indicates to me that our main function was executed. We called into this test get DDB transaction function here. We constructed a couple of data structures here. And then we ultimately sent the asynchronous request to the DynamoDB API. But we don't actually know if it was successful or not. We could have gotten an error because this result type in Rust actually wraps the successful output, which is the transact get items output data structure, or we could potentially have an error if there is an error that gets returned by the API. So what we want to do is check for an error condition. So we'll say if is, we want get transaction dot is error, then we'll just print out a line that says an error occurred while retrieving items with a get transaction. Okay, so let's run our application again after we save that source file. And if there's no text printed out, then it's good to go. But in this case, it looks like we did actually get an error here. So what we're going to do is just do another print line statement. And we'll actually pass in the result of, let's do colon question mark there to turn it into debug output. And then we're going to say get transaction dot error. And that should actually print out the specific error that we are getting here. So it looks like it says missing a region here. And that's kind of surprising because I thought we ran our PowerShell script here that set the AWS region. It looks like maybe that was actually a different shell. So on the right-hand side here, you can actually see I've got two different PowerShell instances running. And when I opened up the PowerShell extension, it actually opened this one here. So that might be where it's actually running those commands. So let's do a cargo run from this different shell. And now you can see we didn't get that error text printed out. So as long as we specify our credentials and the region, everything should be fine. All right, so now that we have got this working, let's go ahead and actually retrieve some data. So what we'll do is just put a return statement here. So if there's an error, we'll print out that there was an error, and then we'll return control back to the main function here. But now what we want to do is actually do something with the result if it was successful, which we just saw that it was. So what we're going to do is refer to get transaction here, and we're going to unwrap it, which will give us the underlying data structure from the success, which is again this transact get items output data structure. We'll do .unwrap here. And then what I'm going to do is refer to the documentation here for this data type. We'll do get transact get item output and open this up. And so once we've unwrapped that, we should have this data structure here that has the consumed capacity if we put it into the request. Remember, there's a specific request parameter that we can use to set that we want consumed capacity. Otherwise, that'll just be empty, I think, since it's wrapped in an option type there. And then we also have this field called responses, which allows us to get a vec of item responses. So that's basically a vector, kind of like an array that we can iterate over for each item that's in the final response. So what we'll do is say unwrap, then we'll grab the responses field here, and that's wrapped in an option type as well. So we'll do an unwrap on that because I'm going to assume that it's not empty for the time being. And then what we're going to do is iterate over each item in the vec. So we'll say for DDB item in this unwrapped result here. Let me put that curly brace up there. And so now you can see that as we iterate over the vec of individual item responses, every iteration, the DDB item variable is going to be set to a new item response. So in this case, we should only have a single item in the vec because we only requested a single item. So what we're going to do is just print out some data here. Let me put in a placeholder here, and I'm going to do DDB item dot. And then we have an item field here that allows us to get an option of hash map of string and attribute values. So we're going to drill into item, and then we're going to say dot unwrap dot get, and now we can get a specific attribute by its name. So we'll do the name of P category. And let me actually take this DDB item here and assign it to a new variable called, let's say, let unwrapped item equal that. And then what we can do is just go and say unwrapped item dot get. And then we can unwrap that again because the attribute here is wrapped in an option type. And then we need to interpret the attribute value as a string. So we're going to call as s on that. And that is coming from the attribute value data structure here. So we've got a lot of different variants of this enumeration. And then when we have a value that we need to decode as an actual Rust string, we can call the as s, and that'll turn the enumeration data structure into an actual string. So we're going to call .as, and then we need to unwrap that as well because it's wrapped in a result type right here. You can see it's a result wrapping a borrowed string value. And so now we can pass that into this. So what I could say is partition key colon, and then we can duplicate this down and get the P underscore name attribute and do the exact same thing. But I'm just going to change this to say sort key and align those right there. So now every single item that we retrieve should just print out the partition key and the sort key from that particular item. So we're basically just spitting back out the values that we are hard coding in right up here. But we're doing it by issuing a transaction and then reading the transaction's response. All right, so let's do a cargo run. And this should just recompile our application. And now you can see it says partition key kitchen, sort key fork. Great, so that's working, right? We have a transaction, a get transaction specifically that is succeeding here. So what I'm gonna do now is actually take these items here. We're going to duplicate these items and get two different items from the table. I should say duplicate these data structures. So what I'm gonna do is say, let get item, Let me just fix the indentation here really quickly. And what we're going to do is just change the sort key that we want to retrieve. So previously I got a fork, and now what I'm going to do is get a different item like a spoon. So let's do spoon, and that belongs to the same kitchen partition as you can see right there. So we're going to get a kitchen spoon, and I'm going to give this a different variable. So get action 02, and then get item. We're going to create a second data structure. So that's going to be get item 02. And so down here, when we wrap the get action here, we need to specify the 02 action. And then we finally need to append another transact item, transact get item here. So we're going to say get item 02. And so now we're appending two different actions into the transaction request. So if either of those were to fail for some reason, then the entire get transaction will actually fail. But if an item doesn't exist, that's actually not an error. So that item will just be skipped over. There are other types of error conditions, though. For example, if the key schema doesn't match up, and so if you specify the wrong key or the partition key or the sort key, that can potentially cause an error. You can also get an error if you have a non-existent table. So when you configure the table name right here, if you have an invalid table that just doesn't exist in the region that you're requesting, that can also cause an error. But as you can see, this succeeded right here. So all we have to do is build out transact get items and get actions for each of the items that we want to retrieve with a get transaction, and that'll take care of retrieving it for us. And all we have to do is just append more if we want more data to get back, right? But let's say that we tried to request the same item. So let's say I tried to build two different requests, but I'm going to try to get the fork a second time. So if we do a cargo run, we should see an error occur here. And so what you're going to see happen is transaction request cannot include multiple operations on one item. So remember, we talked about this a little bit earlier, very briefly. When we build out a transaction that has anywhere from 1 to 100 individual actions, we can only reference a specific item one time for that entire transaction. And so what we're doing here is referencing the same DynamoDB item twice, once up here and once down here. And that is failing because both of those individual get actions are part of the same transaction request that's being sent off to the DynamoDB REST API. So this is just kind of proving out that we do have to specify that we want separate items. Now, to show you the scenario where an item doesn't exist, so we have a kitchen spoon, but we don't have a spoon with a number 2 after it, right? So if I try to run this again with an invalid sort key, then you'll see that it does actually panic here. Let's see why that is happening. I didn't expect that to happen because I thought that we could include an invalid value here, and it is actually succeeding. But the issue is actually that we are assuming with all these unwrap operations right down here, we are assuming that the option type actually has a value. So what we can do is try to unwrap each item. And if for some reason that fails, then we can just skip over the item. And so that's happening right here on line number 43. So what we'll do is say if the DDB item dot is, let's see, dot item dot is sum. So is sum is a function on the Rust option type that allows us to check to see if there is a value or not. And so if it is sum, then we can go ahead and run the code down here. Otherwise, we want to just skip all this stuff, and we don't want to attempt to unwrap an item that is set to none. This is one way of handling it. Another more common Rust way of handling it is to use a match statement, and a match statement allows you to compare an option type to sum or none as well. But this is just another way of handling basically the same logic. Let's do a cargo run here. And again, we should be requesting spoon 2 right up there, which does not exist. And now you can see that we get back just the one item. So the transaction did succeed, even though the second item doesn't exist, but it just doesn't, it returns kind of an empty value for the item that does not exist. So if we just remove the 2, do a cargo run, it should just return both items back to us. And sure enough, there we go. So anyways, that is get transactions. And I think just due to the length of this video, I'm going to go ahead and cut things here, but we will actually talk about write transactions in DynamoDB in a separate video. So I hope that this was educational for you, that you learned something new about DynamoDB, specifically as it pertains to building out a get transaction with the AWS SDK for Rust, and then sending that transaction down here, and then ultimately processing the items in the response from that transaction right down here. So in another video, we'll go ahead and pick up from where we left off and continue by learning about write transactions. Thanks again for watching. Make sure you subscribe to the channel, leave a comment down below to let us know what you thought of this video, and we'll see you in the next video. Take care.